Okay, sometimes we are given scale problems where we may have to find some sort of area. So in this particular problem, it says that a scale drawing of Irvine's rectangular room is 9 centimeters by 27 centimeters and is shown below. So that right here is that scale drawing. The scale is 1 centimeters to 5 feet, or 1 centimeter is equal to 5 feet. So many times when you have a scale problem, you want to start a table of equivalent ratios with starting with exactly that scale. So the scale is comparing centimeters to feet, and once again, it's saying that 1 centimeter is equivalent to 5 feet. So we've got a real world rectangle that we're going to convert to. That would happen to be the scaled copy of that rectangle. So maybe let's start with the side that is 9 centimeters long. So that would be this side right there. And we put it underneath of the 1 because that is the centimeters column. And so you have two choices, and we've talked a lot about this. You can either go left to right multiplier or top to bottom. And I'll just go left to right. So 1 times 5 is 5. And so 9 times 5 is 45. So that is the real length of the side that is represented by 9 centimeters in the scale drawing, and that would happen to be 45 feet. But we also need to find the other side, and that would be the 27 centimeter side. So this side right here. So we'll continue in our table of equivalent ratios. So much like the two other ratios, we can take and multiply the 27 times 5, and that would give us that length in the real world rectangle would be 135 feet, because 27 times 5 is 135. So this side right here is 135 feet. So the question is, what is the actual area of Irvine's room? So in other words, what is the actual area of this? And of course, that would come from the base times the height in that particular problem. And so 135 times 45, 135 times 45 is 6,075 square feet. Another problem that you may run into would look perhaps like this, where once again we're given a scale and we are asked to find the area based upon that. So the rectangle shown below is a scale drawing of Hanita's bedroom. And you can see that it's 8 inches by 11 inches. The scale of her drawing is 1 inch to 2.5 feet. So that means 1 inch on that scale drawing represents 2.5 feet in real life. The question is, what is the area in square feet of Hanita's bedroom? So we've got this rectangle that is the scale drawing. And so we're going to start by taking the scale and creating or starting a table of equivalent ratios. So we are comparing inches to feet. So 1 inch is 2.5 feet in real life. And you can choose where you want to start here, but I'll start with the 8-inch side. That goes in the inches column. And we can either go top to bottom or left to right. I'll stick with the left to right. We know that 1 times 2.5 is 2.5. So then, therefore, to keep the ratios equivalent, we would multiply the 8 by 2.5, and 8 times 2.5 is 20. So what that means is that the actual drawing, this side right here would be 20 feet because that's the side that matches up with 8 inches. And then we're going to do the same thing with the side that is 11 inches on the scale drawing. So once again, we will multiply by 2.5, and 11 times 2.5 is 27.5 feet. And And so this side right here is 27.5 feet. So we want to find the area of that actual bedroom, and so that would come from 20 times 27.5, and that would be, in this particular problem, 550 square feet. Continuing on with scale drawings and area, what we will do here is we will take the scale in our drawing. So what we have here, it says Lee creates the scale drawing shown of a rectangular field. So the 6 centimeters by 19.8 centimeters, that is the scale drawing. So we'll take our scale and we will start a table of equivalent ratios. 1 centimeter is equivalent to 3.5 meters in real life. And so once again, we're taking this scale drawing and we're going to try and create an actual drawing for that. The actual field in square meters. So maybe start with the 6 centimeter side, which would go in the centimeters column there. And we could go left to right with our multiplication. Multiply 1 by 3.5 to make 3.5. So if we multiply 6 by 3.5, that would be 21. So that means this side right here is 21 feet. And then, of course, we've got to do the same thing to find the other side of the actual field. And so now we're dealing with this side that is 19 centimeters, but we will continue with our left to right multiplier of 3.5, and so 19 times 3.5 is 66.5, so that gives us our base and our height of our rectangle there. And so 66.5 times 21 feet is 1,000, because we're going to multiply 66.5, the base times the height, and that is 1,396.5 square meters. And I put feet here, and I meant meters, not feet, meters.